Hello, everyone, and welcome back to the Lightning Talks. We have 10 Lightning Talks for today. Let's see if everybody actually shows up, but I see some speakers here. And we also have 3 pre-recorded talks that we are going to play. So each Lightning Talk is should take around 2 minutes. And with that, I would like to give the stage to Saranjit.
Hi, everyone. Hello, Wolf. Should I be sharing my screen?
Yes, if you can share your screen, that would be great.
Oh, okay. Okay. Just give me a minute. Give me a second. Wolf, can you see my screen?
Yes, I see your screen.
Hello.
You can start. We see your screen.
Okay. Thank you so much. So, hello, everyone. My name is Saranjit Kaur Vogel. It gives me immense pleasure to present a lightning talk at PackagingCon 2021. I congratulate the organizers of PackagingCon 2021 for coming up with such a wonderful conference. A bit about myself. I'm a statistician by training based in India. I had the wonderful experience of working with the developers of Turing.jl during Google Summer of Code 2020. This is how I got more involved with Turing. Turing is created by Honge and is maintained by many volunteers. Turing.jl is a Julia library for Bayesian inference with probabilistic programming. There are quite a few things that make Turing.jl quite efficient as a library. The first thing to notice is that Turing.jl is written in Julia. Given the speed and performance that is usually required for Bayesian inference problems, Turing.jl proves to be a fast, high-performance library. Another feature of Turing is that it is intuitive. The modeling syntax of Turing is easy to read and write. Turing has a special focus on modularity. It can be modified to suit the user's requirements. Whether the models are simple, complex, or hierarchical, they can be specified easily using Turing, making it general purpose. If you are looking to work with Turing.jl, please check the Getting Started page. Also, there are several tutorials available on the tutorials page, including a tutorial on Introduction to Turing. These materials are under continuous development. This is the end of my presentation. Thank you for stopping by. I'm open to questions now.
Thank you. Questions? For questions, it would be good if you can join the gathering.
Oh, great. I'll be there and I'll also share my slides soon.
Thomas, you're on.
Alrighty, let's do it. Hi everyone, my name's Tom. I'm giving this talk, A Modern Approach to Python Packaging, on behalf of myself and my colleague Tiffany Timbers. What this talk is an abridged version of our free and open source book, Python Packages, which basically walks through the packaging development and distribution process from beginning to end, aimed at kind of beginner to intermediate Pythonistas. Why did we write this book? Basically, Tiffany and I come from the University of British Columbia's Master of Data Science program, where we teach Python packaging to students of a variety of skill levels. And what we found is that Python packages have traditionally been one of the most difficult concepts for beginners and seasoned developers to understand. And certainly they can be cumbersome to create. Why might someone feel this way? Well, there's a lot that goes into the packaging process. We have to develop our source code. We have to build our distributions, right? Our FDists and our wheels. We then have to distribute to a software repository like PyPI. Users install from there, they provide feedback, and the cycle continues. And there's also lots of additional work that goes into supporting a package, like writing documentation, writing tests, implementing CI/CD, etc. So the takeaway is that there's certainly a lot to think about, especially for those who are new to Python or software development. And many of the people listening right now will know that the solution to this problem is using one of the many or some of the many mature and modern packaging tools that are now available. So we wrote Python packages to basically show to new users how to use these tools in harmony to make the packaging process more efficient and more enjoyable. A quick shout out to some of the tools that we advocate for, like Cookie Cutter, Poetry, Sphinx, PyTest, and GitHub Actions. These are certainly not the only tools available, but these are the ones we like to use ourselves. I guess the main takeaway from this 2-minute lightning talk is that I want people to understand that packaging does not have to be a burden. Lots of great work has gone into making tools to help make the packaging process enjoyable, efficient, and to make you a better programmer. Thanks so much. And if you want to check out more, see PyPackages. I'll see you in the gathering.
Awesome. Thank you, Thomas. Next up, we have Jeremiah.
Okay. Stage 0 bootstrapping is we have taken upon ourselves to address a problem that's existed since publicly 1974 and realized totality in Ken Thompson's 1984 ACM Turing Award lecture, which was an unsolved problem in computer science for 25 years before David A. Wheeler introduced a way to actually solve it. From there, the Reproducible Builds community and the Geeks community started up and produced considerable progress in solving it. However, they had a great deal of difficulty in reducing the root of their trust. So what we did is we started from the basics, literally hex, commented, and built up ones with basic linkers, ones with proper linkers with names, macro assemblers, C compilers, and I do mean C compilers, and all the way up to GNU mess, which allowed us to bootstrap the entire chain from hex to GCC, Guile, and a full modern operating system. And we have quite a bit more progress going forward, addressing such as hardware bootstrapping, as well as a good many more details, such as addressing the 1958 DoD Nexus Intruder Report problem involving hardware trust. I look forward to your questions, and thank you for your time.
Hello, hi. I'm doing my talk on Basalt Bash Package Manager. So I was looking for the main problem I've been trying to solve is to have reusable blocks of code within Bash. And a lot of the time, most of the time when people do this, a lot of the reusable parts are in one file, and it's kind of hard to reuse and compose functionality. So I wanted to solve this problem. There are existing solutions like BP, GK, and Basher, but I wanted to have a declarative way to declare a package, and it does global and local packages. So, for example, one use case would be installing something like BATS, which is a testing library for Bash. And sometimes distribution package managers are out of date. So here's a method that you can use to install the latest version. And the main use case I was trying to solve is local dependencies. So for example, with the bottom left corner, you see the picture. I knit a package similar to NPM and Cargo just regular package managers. I add the dependency, and the way it installs is everything is in a Basalt folder, and there's a lot of symlinking that goes on under the hood. So when you use code at the top right, you have a little pieces of code, and you run them, and it puts all the functions in the global scope with correct versioning, which is with correct versioning. And at the bottom right, you see a declaration, kind of like a package JSON. And it's just supposed to be a regular package management for Bash. It's supposed to be intuitive. And some of the stuff planned for the future is just extended support. So I want this to be flexible for other shell runtimes and to have custom built-ins. And the project's on my GitHub, hyperupcall/Basalt. And I think that's my 2 minutes. Yes. Thank you.
That was great. Thank you.
I don't think my audio works, but thank you. Yes.
Your audio was perfect.
Awesome.
Okay, next up we have a video file.
Hi, I'm John. I work at GitHub and on the advisory database. I'm at Durakian on GitHub, and I'm here to tell you a little bit about the advisory database. So at GitHub, we maintain a collection of curated advisories as they relate to different package ecosystems. I thought this would be an interesting talk to give to at least raise awareness at a packaging conference, because this is information I think might be useful to people here. We have a GraphQL API if you'd like to get our data this way. The data is all Creative Commons licensed. It's free. Use it as you see fit and to your heart's content. What we're trying to do with this data is to secure the world software. We want to let people know when they have a package that has known vulnerable code, and hopefully encourage them to move off of it. If you've used Dependabot, that's our working model at the moment. All of our data is associated with packages. We try to have it be as meaningful and as rich as possible to support as many use cases as possible. And we source this data from CVEs, language-specific advisory databases, and our own security advisories. If you haven't used our security advisories, this is what they look like. Here's a link in the bottom for a more in-depth discussion of them. Basically, you can tag products. This will go through us. We will confirm that those are the correct products for the advisory, that this is coming from the correct place, et cetera. And then we'll publish it to our database. We want to know what we can do to be better for the community. What other ecosystems should we add? We only support a few at the moment. What, if any, more data should we add? If there's something we're not thinking about, please reach out. There's an email. You can reach out to me on Twitter if you like, whatever. And then to close, an ask from really me, when you're publishing packages, please make sure they are monotonically versioned. I have seen Git hashes, and those are really hard to deal with, or at least hard to talk about. Anyway, that's my talk. Thank you for coming.
Hello to all the awesome people in the Conda packaging world. And hello also to the newbies who have just stepped in and have begun exploring the world of Conda packaging. Like me. Hi, I am Mahiram Khan. I am a computer engineering student from India. And during the summer, I was an intern at Conda Forge. Conda Forge is a community-led collection of build instructions, infrastructures, and distributions for the Conda packaging ecosystem. During my internship at Conda Forge, I learned that if I want to publish a package on a Conda channel, I have to write its recipe. A recipe, I learned, is a file that defines how to build a package. But you see, for a new person like me, writing recipes seemed like a very intimidating process and highly error-prone. But fortunately, I got introduced to this awesome tool called Grayskull, which is an automatic Conda recipe generator. Grayskull can generate recipes for packages that are available on PyPI and also for those packages that are not available on PyPI, but are available as GitHub repositories. This second cool feature was added to Grayskull by me during my internship at Quantsite Labs, which concluded recently. All right, so how does Grayskull stand out? Grayskull, you see, is an improvement upon existing recipe generators like Conda Skeleton, because Grayskull has fewer dependencies as compared to Conda Skeleton. Conda Skeleton has been built upon Conda, which is a huge project. Therefore, it has many dependencies. Grayskull, on the other hand, is a standalone application and does not rely on Conda. It can therefore be deployed on systems without Conda. Grayskull detects compilers and knows Python. Conda Skeleton does not. Grayskull generates very accurate and concise recipes, whereas Conda Skeleton sometimes mixes up dependencies and generates rather fat recipes. Yeah, so we conducted a speed test for Grayskull. We made Conda Skeleton generate recipe for a package called PyTest, and we made Grayskull generate the recipe for the same package. Conda Skeleton took 31 seconds to generate the recipe for PyTest, whereas Grayskull generated the recipe in just 4 seconds. So you see, Grayskull generates better recipes and is 8 times faster than Conda Skeleton. Now, if you want to read more about the awesomeness of Grayskull, you can go to this link, which is the link to Marcelo's blog. Marcelo is, in fact, the developer of Grayskull. If you would like to contribute to Grayskull, we would love that. You can go to this link. So now that you know what Grayskull is, go ahead and use it and make your debut in the Conda packaging world super smooth. Thank you very much. I am Mahe. This is my Twitter handle, Iramahe. You can reach me out if you want to talk about Grayskull or about something else, or if you want to give me a job. Yeah, do reach me out. Thank you very much.
So hello, thank you for having me for this lightning presentation. I'm going to talk about a layer, the library repository or package manager for the Ada language. So it's still Ada around for sure. It's still, it's now a modern language which has been reviewed through the years. It's still a language to go for correctness, maintainability, and basically high integrity development. I want to mention also Spark, which is not a batch Spark, but well-defined subset of Ada that can be compiled with the same compiler, but that is tailored to prove with extra tools statically proof properties of the code, like absence of exceptions, or even full requirements of the code via pre and post conditions. Finally, we are a small community, open source community, but a close-knit one, very friendly. You can find us at the usual places, even some not so usual. About the package manager itself, it's a sandbox, the package manager, so every project has its own dependencies. It leverages the properties of Ada, for example, related to initialization order or dependency compilation on demand and only when necessary. This is automatically checked by the Ada build system. It's designed to work with sources, so packages are downloaded as sources, except for the compilers that are very heavy binaries, so we have them prepackaged as binaries. Finally, this is a package manager fully powered by the community. Everything is done openly in GitHub, and you can find there all the information you want. A bit details of the features, of the more relevant features of the package manager is that it comes with a complete dependency solver. Since Ada can be compiled in several platforms and it can be also cross-compiled for the embedded domains, this is supported by the manifest with a flexible dynamic expression system. Also, we have a pinning system that allows to work comfortably with dependencies that are work in progress, either remote or local. And finally, it has a configuration system that is based on typed variables that can be used by dependents to configure their dependencies. Conflicts are checked. And this can serve, for example, in embedded projects to generate static code for the target. Just a very short demo. So, for example, I'm going to initialize here a package. Once initialized, I can run it. I can add dependencies, for example, a couple of dependencies that will bring in more dependencies, so you can see them. A local dependency I will create now. This is a library, for example, dependency. Once initialized, I can use it directly saying this. And now I can check the dependencies, for example, in a nice tree or in a graph or plain text and so on. Or I can check the versions that need updating. Need updating, which ones are only local and so on. And now with all the dependencies, of course, I should have to build everything. So this is all, because I want to be to the point. Thanks for your attention. I hope if you are interested in embedded development or high integrity software, ADA for sure is a language to know, and you can find us at all those places. And me and the other developers of the project, we will be delighted to see you around. Thanks.
All right, that was an awesome package manager. And that also concludes the first day of Packaging Con. Thanks everybody for attending. I hope you guys can still hang out and gather, or on the Element chat. In Europe, it's pretty late and pretty dark outside already, so I might not be able to join for too long. But see you again tomorrow.